Wonderful. So as we are doing, I think it's like 22nd IoT talks now, and we have done it in more than 11 different countries in Europe. Our main goal when we are coming to the country is to make sure that we bring a lot of industry experts. And are they working necessarily with cellular IoT connectivity or anything else? It doesn't matter that much. We want to make sure that we create this beautiful atmosphere where you guys can mingle, talk with each other, connect, and see if there is some kind of a business possible. So today we would like to talk about the IoT connectivity use cases across the industry. And for that sake, I would like to give a nice warm round of applause for our panelists who will talk about it. So please, welcome. Yes, please take a seat. Wonderful. And I think I need one mic. Is it perfect? It's on. Perfect. Good. So instead of introducing the panelists, I think they would do it much better on their own. So please state your name and the organization you are representing. Let's start with you, Miguel.
So, good morning, I am Miguel Peon. I am from EPFL EcoCloud. EcoCloud is a center for sustainable computing in EPFL.
Hi everyone, my name is Ramzi Bouzerda. I'm founder and CEO of Drupal. We are a Swiss-based company developing an IoT platform for water management in buildings.
I'm Andreas Danuso. I'm the chairman of the InAlp group, which focuses on swarm networking and swarm IoT and everything that comes around of that. And as a side activity, so to say, I'm also a professor of computer science in Bern, and I love that relation to students. And frankly speaking, half of the team in InAlp is coming from the university there. So we make a smooth migration from education to reality.
Good morning. My name is Chiara Melis. I'm based in Lausanne, and I'm part of this wonderful team in Tele2 IoT, and I work in sales.
All right, thank you very much for the introductions. You can keep the mic, and we'll be just naturally passing them here and there. So let's start. I think as a starting topic, it would be quite interesting to talk a few words about the sustainability. So as we have seen in the previous conversations and discussions, sustainability is a very important topic for us as the people on the planet Earth. But also, we feel that we as people working with IoT technology bear quite some responsibility because technology can make sustainability even better. So I would like to understand how, for instance, your solutions are contributing to sustainability and what are your takes on technology and sustainability. And let's start with you, Miguel.
So actually in EcoCloud, we are working on ensuring that IT is sustainable so that we do all the processes as efficiently as we can, but also looking into the complete life cycle of all the servers, all the equipment, IoT devices, everything that is involved in the landscape. But we are also trying to make sure that IT can be used as a driver for sustainability in cities. For example, we were discussing the previous days that we have a very large project with different academic institutions across Switzerland, where we are building a digital twin of the city of Lausanne, where we are putting all the use of water, electricity, transportation, all the energy needs. We are building a model with all the buildings in the city to analyze what are going to be the patterns of electricity needs for heating, for cooling in summer, depending different climate change scenarios, depending how the temperatures will change, and the policies that can be implemented in the cities. So we want that these models also execute as efficiently as possible, and that all the IoT devices that are needed to be deployed in this space around a large city, they can be reused for as long as possible, and they have the least impact as we can get. So.
Over to you.
Thank you. Yeah, on our side, of course, water is a big challenge, as you know all about that. It's not a question now. The question is how we can use technology, IoT and AI to make it more sustainable, to have a more sustainable impact in terms of water, because it's not like energy. Water is energy, energy is not water. So meaning that we need to think about how we can preserve this resource, potable resource, which is very scarce on Earth. Our mission as a B Corp company is to also embed in our processes, in our products, sustainability. It's not just about providing sustainable services, but also how you design your product and services in a sustainable way. We have tried to make our product sustainable, lasting more than 20 years in the field, with very easy to change battery, long lifetime and so on. So a lot of requirements comes with that. On the other side, in terms of mission, once the water enters the building, we are still blind with what we do with water. And in a building, water is not only potable water, it's energy due to hot water consumption. It's also risks due to leakage, but also health risk with Legionella and stagnation. So sustainability is a really holistic approach to change the business, but also serve as a force of good in the market and actually onboard and convince other players to follow that path.
Yeah, the core technology which is developed by InAlp, and probably we will hear it one or the other way here this morning as well, is focusing on swarm networks. And swarm networks are networks that allow you to decentralize the intelligence across geographic areas while still having highest security levels applied there. So I brought such a swarm device with me. This is a small IoT cloud which allows you to, for instance, observe the energy flow in a transformer station of a utility. That's where we deploy that. And this is actually one of our largest market which we are addressing right now, is the mission critical utilities. They are challenged by this change in energy supply. You know that we would like to have PV powered powering, we would like to have electrical vehicles or other stuff, and this is highly dynamic. So if the sun doesn't shine, then the PV power is low, and vice versa when the sun does shine, likewise with the wind. So we need to control much better the energy flows in the lowest distribution grid, which is the NE7 or the 400-volt distribution grid. And we are particularly focusing on delivering technologies and solutions that allow you to use the energy exactly where it has been produced. So we would like, when your neighbor's roof deck presents a lot of PV power, then that's the time when you should charge your electrical vehicle. But this doesn't come without measures. And the measures we provide is tools and hardware and solutions that allow you to decentralize the intelligence and make those kind of stuff work. Likewise, water, we are producing systems to with lowest power ZigBee technology to battery powered for 10 years to analyze the water flow in tubes. And this is really indeed a huge use case.
Sustainability is a topic very close to the heart of Tele2 IoT, and because of that, personally, I'm very proud to work for such a company. As Niklas mentioned before, we've been ranked #1 for Time magazine, and this is based on the ranking of United Nations. Tele2 has been reduced 90% of emissions since 2019, and obviously green energy has been a priority. We are also encouraging customers to adopt energy efficient solutions like NB-IoT and LTE-M. And an example on how we help a company to improve the sustainability is we have a few customers in real-time fleet tracking that use our solution to reduce the consumption of the emission and keep a full control of it.
Yeah, and now we have seen quite a lot of different sustainable use cases across the board, but maybe I can just go one more small round on sustainability. If you have some kind of advice to give to the people who are here watching this online or sitting here today, on how to take sustainability seriously in their company and what are the very practical measures which they need to. I know, Miguel, you have the fantastic answer for that.
No, but actually I want to throw a challenge to the telco operators and the companies who are working on this space. We are working in these digital models in the project Urban Twin, which is Swiss-wide. We are working with some companies that produce sensors for water quality. These sensors work very well. They analyze a lot of parameters of the water, but they communicate over the cell network. So the battery lasts 2 months, 2 to 3 months. We need to go and change the battery every 2-3 months, which is a lot of human cost, but there is also transportation. There is a car going to a place, moving, and then the batteries themselves. We had actually the chance to work for 2 years with Drupal in a project, working with them in making their devices last longer. So you are now in 20 years. So when we were working together, it was around 10, and now they are in 20 years. So that's a huge difference between having to change the batteries every 2 months and having the batteries for 20 years, which is partially on your side, because it depends on different technology for the communication. But this is a very important challenge, how to develop these technologies that allow a more efficient communication so that the batteries don't need to be changed so often. I also wanted to mention a couple of extra points that are interesting, that we want to use also the computation on the edge so that we can reduce the load on the servers. And that's actually quite interesting, because sometimes in the servers, we have all the data and we have to do all the processing on the server side. Sometimes we generate peaks of computation, or we have to do computation when the grid cannot produce enough green energy. So we'll enter into a mode where we demand more electricity, so they have to fire a gas station, for example, to produce enough electricity. However, if we can coordinate with the devices so that they can do the computation themselves during this period, we can modulate the loads that are on the data centers. But now we have a problem. We need to trust the devices. We need to have an agile communication between them. Perhaps they need to exchange data between each other. So how do we trust that I rely to a different device, my part of the computation, in a trustworthy way? And then maybe we can reduce the peaks of computation on the data center.
Yeah, a very interesting example. I would emphasize on the fact that we mentioned connectivity. What I see in the market is connectivity is definitely not simple as we could think. First of all, because each use case requires a specific connectivity. There is no single silver bullet in the market to say, okay, don't matter what connectivity, it will fit your need, because it's wrong. And this is why actually IoT players like Tele2 have a wide range of connectivity solutions, but all of them do not really fit with your requirements. Let's say in the case of Drupal, we serve 100 customers on 5 continents, and we have already 4,000 units in the field. We connect typically everything beyond the main meter in buildings, let's say dispensers, toilets, urinals, anything that consume water in a way or the other. And there, you don't have necessarily access to power, and you certainly know that better than me. It means that you need to run on a battery and in a very long time, and reduce the maintenance cost of your device. And this is where I think one of the biggest challenge for IoT market to grow in the future is to meet all the requirements from the physical world, but also, and as you said, Miguel, is how I can bring AI in the device or machine learning, and how I can share those learnings with the surroundings devices, and finally just use the cloud for necessary computing power and applications. And we are definitely not yet there, and this is why I think AI and IoT will converge, but we need also a more lighter AI in the future to be able to do that.
I certainly agree to the last statement. But coming to sustainability, I guess the world has acknowledged that one of the most important sustainability is achieved by means of decentral energy production on all roof decks and wherever there is energy that could be used and turned into electricity. So that means we totally change upside down our electrical grid that does supply the electrical energy. In the past we had a few, to say so, a few large power plants, be it in the mountain or in a nuclear power plant, and we were pushing the energy from top to down to the millions of users in their houses and apartments. And now what do we say is, we don't need those really. We have a PV plant here, 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 here. We have an electrical car everywhere. That means from a vertical power supply scheme, we go to a horizontal power supply scheme. And that horizontal power supply scheme cannot be managed out of a centralized cloud. It needs decentralization. It needs connectivity. It needs security, because energy supply is mission critical. We see that unfortunately every night a little bit eastbound of here when the enemies are attacking what now? The electrical grid infrastructure. So we need decentralization from the computing engines, and that's why we are focusing on those kinds of devices, which, by the way, can store for a long time hundred thousands of measurement data. These small computers are pretty powerful right now, and we can directly plug them in a trafo station or in a distribution cabinet. But now the question is, how can we reliably, securely connect each of them together? And in between, we do have all sorts of networks with carrier-grade NAT, you know, all those hassles. How can you do that plug and play? And that's exactly the research and the product rollout which we are pursuing, including the necessary server infrastructure that runs and collects data and stores data. And that helps to make the sustainability promise from decentralized energy happen.
From my side, I would just close this interesting conversation by saying that the challenges that we have to face on sustainability are so critical that we will borrow one of the way we work in Tele2 IoT. It's a part of the what we call IoT love, and for us is nothing is impossible until you try to fix it. And this is the way we face such a challenge with our partners.
Thank you very much. And Andreas, you opened actually a super interesting question here, and I would like to use this opportunity to talk about security and the mission-critical communication. Because these days, when you're a company, especially operating in the energy industry or in the security as a vertical and such, you need to have quite a lot of precautions before you launch your product. And you need to be very, very specific about how do you design your IoT solution before it starts scaling. So maybe here, as you are quite an expert in the security field, you can give some of the practical advice also to the listeners in regards to what are the security measures which must be taken in consideration.
Mm-hmm. Okay, thanks for that question. Of course, we do not yet, or we do not reinvent or invent a new encryption algorithm or something like that. I mean, the world has top experts in that domain. That's not our job. Actually, we are basing all of our technologies on WireGuard with elliptic curve cryptography. But exactly these new technologies already paved the way for a more energy efficient encryption, because elliptic curve cryptography is more secure with less power, with less computing power and with less energy power. So Swarm WireGuard is the technology. But now figure out what our aim is and what our goal is to go away from the centralized cloud architecture, because one bomb may eliminate your server. And one crazy guy may prevent, may dictate that your data should be inspected. We know that we have the US Cloud Act. So we shouldn't bet our future there. That's why our belief is we focus, or not There are always different approaches possible, but we focus on what we call a swarm networking architecture. That means we have not occasionally a server, we have maybe hundreds or thousands of those servers which need to be interconnected. So they are installed by a craft person who is not an IT expert. So how can you, and now this comes the next security level, this box is only secure when it's not shitty configured, let me say it this way. So figure out the guy going up the ladder to one of your tubes, installing a device. Should take out a laptop to configure such a device. No go, no go. The only way that you can do this is to have a simple but effective way how you can insert such a device into a swarm by means, and that everybody can do, even on the ladder, take the cell phone, make a photo of a QR code, say connect, and the device is in. And that's where we have patented technologies exactly for that purpose. And now when you have hundreds of those devices, for instance here in Zurich, where is your data? Next question, where do I have, to which server do I have to talk to get my data? That's where we have a directory service overlaying. You don't have to care where the data is. You say, this is the data I need, please give it to me, and you get it. And of course, in between, we need a high-performance networking technology, which is independent, for instance, of LANs of a certain company, because somebody may struggle over the cable or switch off the LAN router, then you are disconnected. That's why this antenna, and that's what I tell to Tele2. Your job is to come to this antenna. Our job is to connect all devices across your physical links by means of logical links. We call that a swarm guard device, and to allow access from wherever. Of course, restricted access only to permitted people. This architecture, that's our contribution to this market.
Yeah, wonderful. Any more security takes? Ramzi, Miguel?
Yeah, thank you. It speaks to me because we help plumbers do IoT, so definitely it has to be dumb and stupid for them as well. It doesn't mean that it has to be insecure, but you need to make it very easy to onboard those technicians, to install and configure and make sure that you don't have some walls here and there. We talked about the device. We use LoRaWAN technology today for most of our applications. We use NB-IoT and LoRaWAN technology. But I would say at the end, LoRaWAN is great, is encrypting the data from nodes to the network servers, but you need to take care of the configuration of your gateway. Again, shitty configuration on your gateway doesn't really help you with LoRaWAN. And at the end, the network server as well, and how you handle the data in terms of privacy. And we have some customers asking us, well, your data are on Amazon, so it's Ireland, but we want them in Kingdom of Saudi Arabia locally, so you need to comply with those rules, and having an on-premise solution and not a cloud solution. And then you start in a journey that you don't know where it will end. And this is really a challenging aspect of security, is just a matter itself, and expert matter itself. It's also, of course, an overhead in terms of cost. And you need to make sure that you adapt that security to the critical mission of your application as well. Because too much security kills the security. So because at the end, if people just bypass all the configuration because it's too complex to do, then you have missed the point. So that's also my conclusion.
Thank you for that statement. Yeah. Simplicity is king.
Yeah. Yes. Actually, I have a background of many years on the biomedical devices. So the people who install our devices are medical doctors or nurses. They more or less know how to install them and how to work with them. But the challenge we find in this case is different, is about privacy of the data. So that in our biomedical devices, when the data is sent to the cloud, people don't want this to happen reasonably. You don't want your EEG to be sent to the cloud where it can be stolen. So there are some clouds that are medically certified with specific measures, and the providers are normally local to the country, so they comply with the local laws. But in general, what we try to do is to avoid that the data goes out of the devices, so that, again, we can increase the amount of computation that can happen locally, but then also that the data can be computed by different devices in a way of federated work, federated learning, a bit the idea of the swarm, but under the devices that you control. So it will happen with the devices you own yourself, for example. So this is a different take on this type of privacy, in this case, more than the safety. Of course, your devices can also be hacked, and then somebody can enter, break all the protections, and steal the data. But they will have to do for all the individual devices that are deployed for every user.
Yeah. Thank you. Chiara, do you have something to add?
No, I can only say that in Tele2 IoT, obviously, we take security very seriously, and we work with private IPN, VPN, cloud interconnect, and this is one of the first things we check when we speak about our client, and the way first we try to understand the business requirement, and the security is a very important topic. Yes.
Yeah, but security is far more important down the antenna, just like Andreas described.
Yes.
There we just handle only the things up the antenna. Listen, one interesting thing here. We have, as you can see, quite a fascinating panel today. And I would like to take your opinions and your thoughts on the general IoT ecosystem here in Switzerland. It is not a coincidence that we have all of those people here today who are in one way or another linked to the academia. So please elaborate on what is making the Swiss IoT ecosystem so special, and what can the rest of the world learn from Switzerland?
So there are two things that I found here. I've been in Switzerland for 7 years. I'm Spanish, from Madrid. There are two things that are very interesting. The first one is that the cities actually are willing to collaborate with us and implement a project. So we went to the city of Lausanne. We want to build a project doing the digital twin of your city. And he said, yeah, great, let's do it. So yeah, of course, then we had lawyers, and there were a lot of discussions on the privacy of the data. We are getting data on electricity, water consumption at many levels. So they had to put in place NDAs and agreements how to do it. But they were open. They were said, okay, let's discuss how to do it, which is not something that normally in many other places, when you go to a city, they say, no, wait, that's too complex. That's something that cannot be done. And the second thing that I was very, very surprised is that companies normally come to universities to work with us, and we can, in that way, listen to the problems that people are having in industry and also propose solutions. We have a very good collaboration, so we do projects with large companies, and then the students that are doing the projects go directly to work in that company, and they become the project leaders immediately after maybe 1 year, something like this. So there is a lot of dynamism there. And the startup ecosystem in Switzerland. That's something that was truly amazed. There are so many people like Ramsey who decide to abandon the normal job. I guess it was a safe job for you in your case. And then decide to start a company. And the students we have doing projects with us, and then the next year they tell us that they have started their own startup, their own company. And that dynamism is something that really amazed me compared to what you see in other countries. And even in quite a few countries, it's not only my own country, there are many other countries where this spirit is lacking. I think this is really, really valuable here.
Yeah, definitely. I would complement with the fact that we have a very strong IoT player in Switzerland, which is Swisscom. I think markets where you have a very strong player like that can really help the ecosystem thrive. We talked about startups. We have very famous startups in the IoT space now, very successful ones in the space, and some others that have been bought by very big companies in the US or in Asia. For example, we have also this, I would say, ability to also keep our foot on the ground, meaning that IoT has also struggled in the beginning to find relevant use cases with business value. And I think in Switzerland, we try to keep this very connected to the technology we develop. And I think that was also one of the key success factors of the IoT in Switzerland. Other than that, I would say I would be more happy if we can adapt more. We develop a lot of technology, a lot of innovation. Of course, Switzerland is known for that. But I would expect more adoption on those innovations, and that will definitely help the ecosystem.
I mean, Switzerland has another advantage by being small. We don't rule everything with 10 laws. Unlike in Germany, when you try to get something done, then you have 10 guys around you and they present you a law that prevents you from doing an innovation. And anyway, the Swiss guys like to do what they want. They don't really care about too many laws. And we want to leverage that spirit of something new, of some innovation, because it doesn't help if the universities don't take me wrong. I mean, I'm also working on a university, but still the inventions are made in a lab and not in the practice. And we need guys who take it out to the field, who work with the technology, and we need kind of our customers as being the field testers first. We can develop new exciting applications, and Switzerland has a favorite role in this because we are not blocked by so many laws. And then there is another thing. I mean, Switzerland does not really exist. We have 26 cantons. So we are a confederation of 26 cantons, and everybody does what they want. And that's a good scenario for us to bring technology out of the R&D lab, of the development lab into the field to get a bloody nose. Actually, I have lots of bloody noses. I'm 40 years in the business, 25 years now as an entrepreneur. I'm a serial entrepreneur. I have grown several companies. I have unfortunately lost a couple of them, but others I have successfully sold. And sometimes I have sold something and rebought it back because the owner was going bankrupt. So I have all those expertise. And we see that field of entrepreneurship is not ending at the university walls. It is going into the business where people are ready to take a risk, where people don't present you tons of rules and say when you comply to all of them, then you can show up again. We say, well, don't care about those rules, let's get something done. And I encourage everybody to do so. You can start on a small edge of your practical garden, let me say it this way, and prove that the technology is viable. And this is very important because that's one lesson which I also learned. In the United States, the innovation is driven by companies. An innovation is only viable if there is a subsequent business. Yes. And we should not make 100,000 patents and 100,000 successful research projects. We should at least drive out 10,000 new products from those 100,000 projects. Yeah.
So the result of these 26 cantons is that for 14 years, Switzerland has been ranking as the world's most innovative economy, according to the 2024 Global Innovation Index. And this is based on the way research and development, some factor like research and development, investment, access to credit, quality of the scientific publication. And the Swiss score last year was a 67.5. And guess who is the second country after Switzerland? Sweden, with 64.5. So this is really a fantastic match between Swiss innovation and a Swedish company like Tele2 IoT.
Yeah, he couldn't summarize it better. Guys, now we are going towards the end of the roundtable, but I would feel very bad if I don't ask you this last question. So just in a couple of sentences, what are the technologies which you are most excited about and what will change the future of IoT in the upcoming years. So, quick fire.
So I think that the most important is going to be in the next years if we manage to offload computation between devices, so we don't depend so much on the cloud, and we can trust other devices to do part of our computation, and we can organize in a kind of a swarm what is going to happen between, so that the computation happens. You say, I want this to be done, not where or how it's going to be done in which devices, but you can trust the result, which is the important part.
Yeah, from my point of view, I think we have seen ChatGPT on really heavy cloud infrastructures. They are building now nuclear plants to run LLMs and such kind of things. I think we are going to also somewhere where we are going to talk about tiny AI, a really small piece of AI that will be embedded everywhere. But we will also change the way we interact with devices. Today, we do some basic JSON requests and flows of data. But tomorrow, it will be all that automated and seamless, even for the users. Because we talk a lot about technicians and so on, but at the end, users are interacting with IoT devices. And today, it's via your smartphone. But tomorrow, it will be with your voice, with your eyes, with everything. And it's already the case. So I think there is a fusion going forward with IoT, with AI, and human interfaces that will make all this seamless.
Yeah. I mean, of course, there are different technology approaches, and I mean, centralized IoT infrastructure has also their benefits. But we, and that's me and my companies and my environment, we focus on the decentralized IoT stuff. And very important is, of course, their physical connectivity, the logical connectivity in terms of swarms. That's what we do. But we need physical connectivity, right-sized physical connectivity. We don't need the megabits per second. We need the kilobits per second, but we need them everywhere. And we need them 5 stories underground. We need them in the middle of a meadow. So that's what I call the physical connections are vital to that scenario. And probably sooner or later we need also to consider satellites. In particular, if we consider the sad scenario of having warfare everywhere, then even antennas can be blown away by bombs, but the satellites also they can be harmed. But I think the connectivity, wireless connectivity space is really something that is important, and it needs to work. And that's a little bit the problem of the best effort, everybody contributing LoRaWAN technology, which is not always reliable. We cannot bet on that, because if we have a critical situation in an electrical grid and the LoRaWAN is not working, then we are in troubles. And that's why we think that narrowband cellular technologies at an attractive price, not overpriced, is very important. And we don't need to watch TVs across those links. We need to send every 5 seconds some 10 or 20 bytes, and that's it. And we think that this opportunity should be addressed.
For me, is how AI and IoT can be combined in order to create additional value. And we already saw some example during our visit at the Ecolab in EPFL with Miguel. So this is the future topic for me to explore.
Absolutely. Guys, any questions in the audience to the panelists? If not an obvious one, I think that you can grab them during the coffee, and we can talk about IoT and technology with these guys for hours and stuff, but I think now we need to go to the branch. So guys, thank you very much. Very insightful panel. Please give them a nice warm round of applause. Thank you. You? Thank you.
eSIM is definitely a key.
So we were working with a Simula Lab in a project it's called Monroe, funded by the European Commission. And it was between 2014-17. And we were getting SIM cards from different operators, putting them in embedded devices and sending them to different places. And one was in a school in Svalbard. So we sent it with 3 operators.
I finally found you, Miguel. Okay, thank you very much, guys. Thank you. And with that being said, I think it's time for us to close the IoT Talks in Zurich. Thank you very much for your attention. I think we had some very interesting, insightful conversations. And I welcome you to join us for a wonderful brunch there. Thanks again.